Question 13. We're looking at KB here, and we are given the POH. So let's take a look at how we manage this. First of all, we do our equation. Let's get a brush first, and we're going to start out with X, and we're going to add water to it because we are dealing with KB, which means we need OH minus. The OH minus has to come from somewhere, so it's going to come from the water. And when we are trying to figure out what goes with this, my advice in questions 8 and 9 was to add H plus to whatever else we had. So we've got water, which turns into H plus and OH minus. The H plus gets added to the X, so it becomes XH plus. Effectively what you're doing is adding H, and the sign goes up by 1. So let's see, initial is going to be 0.67. This is going to be 0. That's going to be 0. Equilibrium, .67 minus Z, and Z, and Z. So now we need to look for this OH minus here, and we are given the POH. Now what we know is that POH here is equal to 1.1, and the concentration of OH minus will be 10 to the negative POH, which is 10 to the negative 1.1, which is going to be 0.079. Now this also happens to be the Z value as well, the concentration of OH minus. We can find our KB value, which is going to be XH plus times OH minus over X. The XH plus and the OH minus, that's Z squared, which is taking these values directly from the equilibrium concentrations, and 0.67 minus Z. Now the Z is going to be 0.079, and that's going to be squared over 0.59. Now where I get that from, it's 0.67 minus 0.079, two decimal places. So the answer comes out now to be 0.0106, but if you were putting this on a test, you'd put 0.011, because that would take it down to 2 sig figs. I've left it as 3 sig figs because it helps me with my grading on this question.